So we're going to start with problem 13, which is the next one. So let's look at the pattern again. 1 is equal to 1 squared. 1 minus 2 is equal to negative 1 squared. That's negative of the quantity 1 squared. So it's not negative 1 quantity squared, it's negative the quantity 1 squared. Okay, the next one we have is 1 minus 2 plus 5 is equal to 2 squared. 1 minus 2 plus 5 minus 13 is equal to negative 3 squared. And then we have 1 minus 2 plus 5 minus 13 minus 13 plus 34 is equal to 5 squared. So hopefully what you're seeing here, this pattern, is we have the, let's write the terms in the Fibonacci sequence. So we have 1, 1. 1 plus 1 is 2. 1 plus 2 is 3. 2 plus 3 is 5. 3 plus 5 is 8. 5 plus 8 is 13. 8 plus 13 is 21. 21 plus 13 is 34. And then we get 21 plus 34 is 55. 55 plus 34 is 89. So I think that's far enough to go along. So what you can see is this particular side is taking this one, this one, this one, and this one, and then this one. So the next one is going to be 89. So we're going to have 1 minus 2 plus 5 minus 13 plus 34 minus 89. 89. And on the right-hand side, we're going 1, 2, we're just going straight through here. So we're just using each one in sequence. So we're not skipping over anything. So the next one is going to be 8. And it's going to be negative that. So it's going to be negative 8 squared. So let's confirm this is correct. So if we take, I'll use my calculator, 1 minus 2 plus 5 minus 13 plus 34 minus 89 is negative 64. And so we have negative 8 squared. 8 squared is 64, and so we get that working out. So it's kind of cool. There's all these weird patterns that you can get using the Fibonacci sequence. Okay, number 15. Yeah, let's do 15. Every natural number can be expressed as a sum of Fibonacci numbers, where no number is used more than once. For example, 25 is equal to 21 plus 3 plus 1. Express each of the following in this way. Actually, we have the numbers over here in the left column, so that works out handily. So 37, we need to say 37 is the sum of Fibonacci numbers. So I have 31 plus 3 plus 2 plus 1. And they don't have to be in sequence or anything, but actually that's not right. It's 21. Where did I get 31 from? Oh, I know what it is. Sorry. It's 34 plus 3. But if there's any other ones that would work. Well, yeah, we could add these two, which give us 34. And then we could do that. We could add okay. I was just wondering whether you could do the other one. So you could do 21 plus 13, which would be 34 plus 3. Let's see if we can do anything else. Let's try. Well, 13 can be represented by, could be substituted with 8 and 5. So that would work as well. So you can do one with 5. So 8, 5, 3, well that's not going to work. So if you do 13 plus 8 plus 5 plus 3, so that's 21 plus 8 is 29 plus 2. That's not going to work. Okay. B. So that was A. B is 40. So again, you could take 34 and 34 plus, let's do 5 plus 1. That would work out. You can also do 34 plus 3 plus 2 plus 1. That would also work. How about 21? 21 plus 13 plus 3 plus 2 plus 1, because these add up to 34. Anyway, multiple ways of doing it. And then we have 52. 52 is, take 34 plus, let's see what's next. Well, if we added 13 to that, we'd get 47 plus 13. So that's 47. I need 6 more. So I could do 5 plus 1. I could do, that's 6. So I could do 3 plus 2 plus 1. So there's multiple ways. That doesn't sound so spectacular to me. Okay, let's look at 18. For any prime number p except 2 and 5, either f sub p plus 1 or f sub p minus 1 is divisible by p. Show this is true for the following values of p. Okay, so part A is p is equal to 3. So p plus 1, well, f of p plus 1 would be f of 4. And let's write them down again. So you get 1, 1, 2, 1 plus 2 is 3, 2 plus 3 is 5, 8, 13, 21. Okay, so those are the Fibonacci numbers. This is the number 1, 2, 3, 4, 5, 6, 7, 8. These are subscripts. So we're looking at here is f p sub 1 is 4, p minus 1 would be equal to f2, and f4 is equal to 3, and f2 is equal to 1. Okay, so what does it say? It says it has been shown, this is 18. For any prime number p except 2 or 5, either f sub p or f sub p plus 1 or f sub p minus 1 is divisible by p. Either or. Okay. So f sub p plus 1 is divisible by p. So 3 divided by 3 is equal to 1. For the second case, 1 divided by 3 is not equal to a whole number. Is not equal to a whole number. So that doesn't work. But it says or. So that worked out okay. Again, that's not too spectacular. Let's try p equals 7. So p equals 7. So f of p plus 1 is f sub 8, the 8th term in the Fibonacci sequence, which is 21. And f of p minus 1 is f sub 6, which is equal to 8. So are these either one of these divisible by 7? Yes. F sub p plus 1 divided by 7 is equal to 21 divided by 7, which is 3. It doesn't work for 8, so it works for one of the two. And the final one is p equals 11. Okay, so I need to add a few more terms here. We get 34, 55, 89. So that's the 9th, the 10th, the 11th, and the one more term. So that's 14, that's 144, that's the 12th term. Okay, so the 12th, I need f of p plus 1, which is f of 12, which is 144, and I have f of p minus 1, which is f of 10, which is 55. So are either one of these divisible by 11? Well, f of p minus 1 divided by 11 is equal to 55 divided by 11, which is 5, which is, the other one doesn't work. 144 divided by 11 is not a whole number, or natural number. What is it? 144 divided by 11 is 13.09. So one of the two. Turns out in this case it's f of p minus 1. Okay, what are we going to do next here? We're going to talk about the Lucas sequence. We'll do 21. So, this is one of the Fibonacci type sequences that's been studied by mathematicians. It's the Lucas sequence, named after a French mathematician of the 19th century. The first 10 terms of the Lucas sequence are 1, 3, 4, 7, 11, 18, 29, 47, 76, and the next term is 123. So the only difference is that the first two terms are different. We had 1 and 1 as the first two terms of the Fibonacci sequence. Here it's 1 and 3. So 1 plus 3 is 4, 3 plus 4 is 7, 4 plus 7 is 11, 4 plus 7 plus 11 is 18, 11 plus 18 is 29, etc., etc. So the next term is just going to be 76 plus 123. So let's just add those. So you get 3 plus 6 is 9, 9, 1. So you get 199. Okay. Let's look at 22. Choose any term of the Lucas sequence squared. Then multiply the terms on either side of the one you chose. Subtract the small result from the larger. Repeat this for a different term of the sequence till you get the same result. Okay, so let's just figure out what that says. Choose any term of the Lucas sequence. So let's pick 18. Squared. So 18 squared is 324. Then it says, then multiply the terms on either side of the one you chose. Well, the other ones would be 11 and 29. So multiply that. 11 times 29 is 319. Subtract the smaller result from the larger. 324 minus 319 is equal to 5. Do this for a different term. Let's pick 47. 47 squared. 47 squared is 2,000. Is 2,209. So let's take each term on either side, which is 29 and 76. 29 times 76 is equal to 2,205. Subtract the smaller one from the larger one. Oh, it's 2,204, not 2,205. Subtract these, and you get 5. Okay, how about that? Make a conjecture. Okay, so the conjecture is if you take the nth term, square it, and subtract off the n minus 1 times the n plus 1, you get 5. Okay, let's look at 23. First term of the Lucas sequence is 1. add the first and third terms. 1 plus 4 is equal to, let's write down it. It's over here. We can just look over there. So 1 is the first term. 4 is the third term. You get 5. Record your answer. Now add the first, third, and fifth terms. First, third, fifth terms. And what do we get? We get 16. Okay? First, third, fifth, continue this pattern each time, adding another term that is in the odd position. 1 plus 4 plus 11 plus 29. Okay, so 29 plus 11 is 40, plus 5 is 45. Let's do one more. 1 plus 4 plus 11 plus 29 plus 76 is equal to, well, these add up to 45, so we just add these two numbers together. And so you get 110 plus 11 is 121. Okay. Continue this pattern each time. What do you notice about all of your sums? So 5, 16, 45, 121. Do we notice anything here? 5, 16, 45, 121. So basically, this is the Lucas number 7 minus 2. This is the Lucas number 18 minus 2, which is there. Then you have 47 minus 2, which is 45. And then you have 123 minus 2, which is 121. So that's the pattern. Okay. So whether to stop there. Yep, I think we'll stop there.